All right, problem number 56, and we're going to try to roll right along nonstop. Write a polynomial function with real coefficients in factor form if the zeros are -2, -3, -2, 3, and 5. Alright, so again, writing that polynomial would be f of x is equal to, if the 0 is -2, then the factor is x plus 2. If the 0 is 3, this is x minus 3. And if the 0 is 5, then this is x minus 5. Alright, for number 57, it says the same thing, but the zeros, and it's a lot like the one that was pictured. The zeros are 0, 4, 7. Alright, and so the polynomial would be x, instead of writing x minus 0, if you wrote x minus 0, you wouldn't be totally wrong. It's just not the right way to write it though. Alright, 0 is 4, so it's x, the factor is x minus 4, and this is x minus 7. Alright, in factored form. So these are factored forms for those problems. Number 58. Alright, it's going to take a little bit. Alright, but we can definitely do number 58 on here. Alright, determine if each expression below is a factor of x cubed plus 6x squared minus x minus 30. And in my class we talk about having a degree of every term. Alright, and for this problem there is one. Alright, you got x cubed, this is a third degree, and this is 6x squared. Alright, we don't have to placehold in order to use synthetic division, and all we want to do is use synthetic division. Alright, we're using the remainder theorem to find out whether or not we have a remainder. Alright, and so basically there's 6 problems here. Alright, the first one, the factor we're checking is x minus 2. Alright, and all we want to be able to do is whatever we're dividing, we want to be able to set it equal to 0 to figure out the value we're using. Alright, and so the value we're using is 2. Alright, we go 2. We use our coefficients, so we go 1, 6, -1, -30. Alright, and as we go down, we combine. So we bring our 1 down. As we go up diagonally, we want to multiply by the value we're using. So 1 times 2 is 2. That's 8. As we add up diagonally, that's 16. Add, this is 15. Multiply by 2 as we go diagonally, that's 30. And we end up with a remainder of 0. So x minus 2 is yes. Alright, we do the same thing over and over. So b, alright, our factor is x plus 6. Alright, so we set it equal to 0. Alright, that's saying x is going to be -6. Alright, here we want to keep that ball right there. Alright, and check again. So we got -6. Our coefficients, same coefficients again. Alright, I bring down my 1 as I multiply times this number is -6. I get 0. I get 0. I add, I get -1. Multiply by -6 again, and that's going to give me 6. So I add these, and this gives me -24. So that is a big fat no. Alright, C. Then the factor is x minus 5. Alright, and so if I set that equal to 0, I'll get x is equal to 5. Alright, that's the value we want to use. Alright, 1, 6, negative 1, negative 30 again. All right. As I go down, I want to bring the first number down, up, multiply by 5, gives me 5. This gives me 11. Multiply by 5 again, that gives me 55. Add, this gives me 54. Multiply, that gives me what? 200. No, what's 5 times 54? All right, 270. All right, add, that gives me 240. All right, and my remainder is 240, so x minus 5 is not a factor. Not or no. All right, we keep going. D. All right, D, we have x plus 2. All right, we're going to set it equal to 0. X is equal to negative 2, so that's my value. All right, 1, 6, negative 1, and negative 30. All right, bring the 1 down, multiply by negative 2, that gives me negative 2. Add, that gives me 4. Multiply by negative 2, that gives me negative 8. Yes, and that's negative 9. Multiply, that gives me 18. That gives me negative 12. My remainder is my last number, so that's a no. All right, let's keep going. E. Letter E is x plus 3. All right, I'm going to set it equal to 0. That's going to give me x is equal to negative 3. So my 0 is negative 3. All right, my coefficients again from the beginning were 1, 6, negative 1, negative 30. That's 1. Multiply by negative 3 by the 0. That's negative 3. That's 3. Multiply by negative 3 again. That's going to give me negative 9. Add, that's negative 10. Multiplied by negative 3, that gives me 30. And I get 0. Yes. So this one's a yes. All right, and then the last one, I'm going to try to squeeze it on this board. All right, the last one is x minus x plus 5. All right, we're going to set it equal to 0. That's going to give us x is equal to negative 5. What letter is this? F. All right. All right, so my number, or my 0, or my root, all right, is negative 5. That's 1, 6, negative 1, negative 30. All right, let's check it. Bring the 1 down. Multiply by negative 5. Add that, that's 1. Multiply by negative 5. Add that, that's negative 6. Multiply by negative 5, that gives me 30. And that gives me 0. So the last one works. Yes. All right, so that was A was a yes, B was no, C was no, D was no, E was yes, and F was yes. All right, number 59 says to divide. It doesn't tell us to use long division or a synthetic. I'm going to use synthetic. All right, so our factor is x minus 5. We're going to set it equal to 0. All right, and that means our 0 is 5. So there's our number. We have a degree of 3 polynomial, but there's a 3, there's a 2, there's a 1, and there's a constant, so we're good. We take our coefficients, 2, negative 9, negative 8, 15. And remember, as we go down, we combine. As we go back up diagonally, we multiply by the number. So that bring down the 2. 2 times 5 is 10. Add the numbers, that's 1. Times 5 gives us 5. Add the numbers, that gives us negative 3. Times 5 is negative 15. All right, and then that gives us a remainder of 0. All right. So one thing that we know that x minus 5 is a factor of this polynomial. All right. We write the rest of our answer using this as our constant. All right. This is our x term. This is our x squared term. All right. If we had more, this would be our x cubed. This would be our x to the fourth and so forth. All right. But this is what we have. So what we're going to say is 2x cubed minus 9x squared minus 8x plus 15 divided by x minus 5 is going to give us 2x squared plus x minus 3. That's the final answer. All right, number 60 says, given the polynomial, sketch the graph and find the zeros of the function. All right, describe the left end behavior and then describe the right end behavior. All right, so we got a lot to do in this problem. I would suggest starting with the calculator, all right, especially since you can. All right, we're going to type the equation in. All right, so I have x math 3 plus 3x squared minus x minus 3. All right, get an idea of what the graph is looking like. And right away we see that there are 3 zeros. All right, the degree is 3. All right, it doesn't look like it's going to be too difficult to graph here. All right, I guess we can graph over here. All right, we don't want to take just, exactly what's from the graph, but we kind of get an idea of what the graph is going to look like. We can go to second table and check our zeros. All right, and you can see that you have 1, 0 at negative 3, comma 0. One of them is at negative 1, comma 0. All right, and one of them is at 1, comma 0. All right, you got those. If you want to take a couple of other points, you see right here, 0, negative 3 is your y-intercept. All right, while we're at it, we can, I guess we can take negative 2, 3. 1, 2, 3. All right, plot that. I'm not sure if those are your minimum and maximums, but they definitely look close to being your minimum and maximums. We can always go and check, and so we want to check our maxes and mins. All right, so we're going to check this local max here. All right, we check that by going second calc max. All right, it looks like it's at what, 1, 2. It looks like it's at 2, but I'm going to left bound, right bound it a little bit to the left of where I think it might be. So I'm going to say negative 3 is my left bound, and I'm going to say negative 1 is my right bound, and I'm going to check that. All right, it says that my max value, which was not this, is at negative 2.1547. Oops, let's go 55, comma 3.079. All right, and we're going to check that minimum, check for that minimum. So we're going to go second calc again. Second calc, min. And it looks like it's near the y-intercept, so we'll say negative 1 to 1. All right, negative 1 is our left bound, 1 is my right bound. All right, and so my minimum, my local min for this problem is 0.155, negative 3.079. All right, so It's very close to these values, but it actually goes a little bit further down. We can now usually if you write your local and you say that it's local. All right, since it can't be the absolute, since this graph goes all the way and all the way up and all the way down, you give your zeros, 1 0, -1 0, and -3 0. All right, check and make sure those were right. Yep. You have your, all right, you also have a point at, what was that, 0, -3. All right, your y-intercept. I think that looks good. All right, so that's all of A. B. All right, it's asking you to describe your left-end behavior for B. All right, LEB. All right, remember we always start this by saying as x approaches -infinity. All right, what does y do, or what does f of x do? You can write y or f of x, it doesn't matter. All right, and this graph goes down, so it's -infinity. And your REB is as x approaches infinity, y approaches infinity. All right, and I think that's all that's all the questions. All right, remember labeling. If you write it down here, then we know that we're talking about your local maxes and local mins. Just make sure you label those values. All right, for number 61 and 62, basically the same problem. All right, it says determine if each number below is a possible rational root /0 according to the rational root 0 theorem. All right, write yes or no for each number. All right, so in order to do that, all right, some people use P over Q. All right, and all that stands for is your factors of your constant over the factors of your leading coefficient. LC stands for leading coefficient today. All right. And what we have for 61 is f of x is equal to 4x to the 5th minus 7x cubed. So it's already in standard form for us. Squared plus 15. All right. So our constant is 15. All right. And our leading coefficient is 4. All right, we want to give the factors of those. So we say plus or minus. Well, how can I get 15? 1, 3, 5, and 15 over the combinations of 1, 2, and 4, the factors of 4. All right, and so if we were to list those, all right, we're going to go 1 over 1, 3 over 1, 5 over 1, 15 over 1, 1 over 2, 3 over 2, 5 over 2, 15 over 2, 1 over 4, 3 over 4, 5 over 4, and 15 over 4. So all the possibles would be 1, 3, 5, 15, 1/2, 3 halves, 5 halves, 15 halves, 1/4, 3/4, 5/4, and 15/4. And those would be positive or negative. All right, so then we can take the problem and check. Well, A says it's 5, 1, and 5 is up there, so it gets a yes. B, -1/4 is 1/4 up there, yes. C is 3/2. Yes. D is 4 up there. And no. E is 1/3 up there, and that would be a no. All right, and so that's all we're doing for 61. All right, number 62 follows the same situation, but the question is asked a little differently, just a little differently. All right, it just asks you to list them. All right, so we listed them for the last one, but this one is asking you just to list them, not yes or no. All right, and so for number 62, all right, we have a constant. There you go, P over Q. All right, your list of constants, factors of constant, of your constant. Ooh. And the factors of your leading coefficient. All right, so my factors of my constant. Well, what is my constant? 4. All right, what's my leading coefficient, guys? 5. All right, and so the factors of my constant are 1, 2, 4. Factors of my leading coefficient are 1 and 5. All right, and so if we list the possibles, all right, our possible rational roots, all right, they are 1 over 1, 2 over 1, which is 1. Make sure you got plus or minus with it. So we say plus or minus 1 over 1, 2 over 1, 4 over 1, 1 over 5, 2 over 5, and 4 over 5. Got it? And we're done. Number 63, it says let f of x equal x to the 4th minus x minus 4. A, how many zeros does this function have? And then B, based on its graph, how many real zeros does this function have? All right, so obviously we should, well, first of all, for A, all you need to know, if you want to know how many zeros something has, all you do is figure out the degree. All right, and the degree is the what? Highest exponent. All right, and so in this problem, f of x is equal to x to the 4th minus x minus 4. The degree is 4. All right, and so it has 4 zeros. Now, they don't all have to be real. Only way you can see that is to graph it. So let's graph it. X to the x caret 4 minus x minus 4 and graph. All right, and we look at the graph. It looks something like a parabola, right? Not quite a parabola. All right, it can't be a parabola if it's x to the 4th, but we do see that we have 2 real zeros because that's how many times it crosses the x-axis. All right, you have 2 real zeros based on the graph. So it doesn't really ask you about the imaginary, but if you have 2 reals, you probably have 2 imaginary. All right, that's that. All right, and number 64 is just very similar to 63. It's just a multiple choice question. It asks you, how many zeros does f of x have? Well, f of x is equal to x to the 5th, highest exponent, so that's the degree. So it must have how many zeros, guys? D, 5 zeros. Now, doesn't mean that they're all real. How do we figure that out? Well, we have to base it on the graph. So let's go to the graph. x caret 5 minus 3x square minus 4. Graph it. All right, and from this graph, wow, from this graph, it looks like it crosses the x-axis once. All right, and if it only crosses it once, then based on the graph, how many real zeros do you have? Well, you have one real zero because you only cross the x-axis once.